if the any electron, that means the electron is absorb the energy, it is goes to the excited state. So in the excited state, the electron is not stable, so that it will be jump into the different states. Due to the different state jumping of the electrons, the lines are formed. Those lines are 5 categories that will be explained by that one. And in this case particularly, the electron, where the electron is present in an atom, how it is location, where the location is there, where that means it will be rotated clockwise or anti-clockwise, or in which axis, that is explained by the quantum numbers by means of the 4 quantum numbers: principal, magnetic, that is a principal, azimuthal, magnetic, and spin quantum number. You can identify the electron in an atom. So by means of the 4 quantum numbers we are identifying. That will be the last class we are discussing about. And the next is the in the particularly Pauli's exclusion principle. What is Pauli's exclusion principle? So Pauli's exclusion principle means Pauli made some restrictions on the Pauli exclusion means some restrictions on the quantum numbers. Why? Because what he says that definition, first of all, I will define that one particular Pauli's. What is given as no 2 electrons in an atom can have the same set of identical 4 quantum numbers. That means nothing is there more. We are having the 4 quantum numbers. ఏవైనా 2 ఎలక్ట్రాన్లు 4 క్వాంటం సంఖ్యలు సమానంగా ఉండొద్దు అని చెప్తాడు. No 2 electrons can have the same set of 4 quantum numbers in an atom. Suppose you see that one. What is the meaning of n is equal to 1? It is the first orbit. In that first orbit, L is equal to 0, M is equal to 0. Okay, so M is equal to 0, and this is ML, and MS value is the first electron. It is clockwise direction. It rotating clockwise direction. Same in the first orbit. Same in the s orbital. That ML value also 0. That means it is a SR. Why? Because it is only one room. But one more electron will be rotating in anti-clockwise direction. These are the 2 electrons which are present in an atom. That means already I told that in each sub shells it holds only 2 electrons. In the 2 electrons, all the 3 quantum numbers means principal quantum number, azimuthal quantum number, magnetic quantum number is same. But the spin quantum number, one electron must be clockwise direction, another electron maybe must be anti-clockwise direction. That is given by the Pauli's exclusion principle. No 2 electrons in an atom can have the same set of identical 4 quantum numbers. ఏ 2 ఎలక్ట్రాన్లు కూడా 4 క్వాంటం సంఖ్యలు సమానంగా ఉండకూడదు. అట్లీస్ట్ ఒక క్వాంటం సంఖ్యనన్నా డిఫర్ అయి ఉండాలి. కనీసము ఒక క్వాంటం సంఖ్య డిఫర్ అయింది. దిస్ ఆర్ డిఫరెన్స్ బిట్వీన్. వై? బికాస్ ఐ am using of the Telugu words which will be easily to understand this particular concept. But the meaning of the no 2 electrons in an atom can have the same set of 4 identical quantum number. That means at least one quantum number should be differ. What quantum number is differing here? Spin quantum number is. Why? Because we are already know that one electron must be rotating clockwise, another must be rotating anti-clockwise. Due to that reason, the Pauli's exclusion. It is a 5 marks question for your examination point of view. Now coming to the next topic, I will go into the very fast that one. Eisenberg's uncertainty principle. It is also every time repeating question. This is the Eisenberg's uncertainty principle. What is Eisenberg's uncertainty principle? Before that, I am using up so many examples are there for understanding of this particular concept. Why? Because here in this atom, the electron is the smallest particle which is moving very fast. For that purpose, he derived one principle that is called as Eisenberg's uncertainty. Uncertainty means there is a not certainty is present. That is called as principle, uncertainty principle. So for that, I am using of the one example, beautiful example. Suppose I am taking the class offline class I am taking. So I am already started the class. Some of the students are sitting in my room. So I am started the class. Some of the students are coming now. Already my voice is audible. That means it is listened. Oh, Saad is already started. Come, go fast. So the students are coming fast. Why? Because I don't want to allow after the 5 minutes. That is the reason. So due to the reason, what happened? Immediately the students will be run away very fast. But my intention is when students are crossed a particular place, particular position. That means I'm identify the position, and they are coming very fast and click the photograph. So what I can getting of the exact position, you are crossing the whatever the border, just I'm click the photograph. So I getting of the exact position. But how is your momentum? Momentum means velocity. Velocity I can't calculate accuracy. Why? Because you are very in hurry. Why? Because already class started. That is the situation. I can't calculate exact of the velocity. I hope you can understand this particular example. While I am starting the classroom, so I think that you are taking up the photograph while you are crossing one boundary. That is a position of your boundary. You are crossing that boundary, I can click the photograph. So I can exactly calculate the position. But what about your velocity? How much you are fast coming? You can't calculate exactly. You can calculate some amount. Velocity is calculated, but exactly we won't get. That is called as unexact. Uncertainty is there. That is given by the Eisenberg uncertainty principle. Why? Because it is impossible. I'm saying the definition of Eisenberg uncertainty principle. It is impossible to calculate simultaneously and accurately. It is possible, impossible to calculate simultaneously and accurately. Okesari Mariu Kachitanga. This is both the words we are using by the Eisenberg. It is impossible to calculate simultaneously and accurately of a fast moving particle like electron in an atom is called as Eisenberg's uncertainty principle. He given one equation. The uncertainty in that means delta x is the position and the delta p is the momentum. Is almost equal to the Planck's constant. The product of the uncertainty in position and uncertainty in momentum. Momentum means P. P is nothing but the momentum. This is nothing but mass and velocity. Your mass and velocity. During of that one, we are getting, or you can write out this equation: delta x into m delta v is almost equal to the h by 2 pi. It is given. Both the equations are given by the Eisenberg uncertainty principle. I hope that you can understand the concept of this particularly. That the main definition is it is impossible to determine simultaneously and accurately the position as well as the momentum of a fast moving particle like electron in an atom. Why? Because in the atom, electron is moving very fastly. You can't calculate exactly and simultaneously both the position as well as its velocity. That is called as Eisenberg's uncertainty principle. Okay, friends. So this is also a 5 marks question. I don't want to elaborate everything in this case particularly. Next, above principle, we are adding up the one rule is there. That is before that. The shapes of the orbitals also given by that one. After the shapes of the orbital, I will go to the shapes of the orbitals. It is also 5 marks bit. So first s orbital. S orbital is what is the shape? It is a spherical one. It is a spherical shape. So you can draw it is a nucleus. So in this nucleus, the electron cloud like this. Anywhere the electron may be present, the probability of finding of the electron is like this. This is the 1s. Suppose if you want the 2s means it is a center, that is a nucleus. Okay, this is the first orbit. Like this is a 2s. The size is increases. That means it is a spherical one. Coming to the p orbitals. P orbital is the dumbbell shape. And also they are having of the 3 orientations. According to the magnetic quantum number, 3 orientations. Those are px, py, and pz. So how they are? Please go through this one. My technique, I'm using the technique is just through using of the place or the cross mark, whatever you want. So taking of this place mark, suppose you are using of the axis. This is the x-axis. This is the y-axis. Okay, z-axis is there here. This is the z-axis. Why? Because the Cartesian coordinates are 3, x, y, z. Now, in this particular case, what you have? You want the px. So, at the px, just see this one px. I am writing off. See that this is the px. This is nothing but px orbital. Now, I'm taking up the same X, Y, Z. Okay, friends, here on the Y, a dumbbell is present. On the Y, see these two are dumbbells, that is the lobes are identical. Identical lobes are present. This is called as PY. See how it is easy to drawing in the examination. Why? Because it is a 5 marks question. Next is a Z orbital. That means PZ you want. That means this PZ is like this. So you have to draw. This is the PZ. Sorry, it is a Z axis, it is a X axis, Y axis. See how it is easy. You can draw like this. Easily. That means you can keep first put as a 3 plus marks. On the plus marks on the X axis you are drawing the one dumbbell. It is called as a PX. On the Y axis you are drawing the dumbbell. It is a PY. On the Z axis you are drawing the dumbbell. That is called as a PZ. This is about the p orbitals. That is the shapes of that one. Then after there was the d orbitals also. Why? Because you have to draw the shapes of the orbitals. All the orbital S, P, D, F you have to draw. Spherical, easily to draw. And dumbbell, easily to draw. Next is the d orbital. That is a double dumbbell. How it is d orbital? We'll show that one. That is also easy technique. D orbital. D orbitals is double dumbbell. The shape is okay. And orientations are 5 orientations are there. That means 5 rooms. 5 orientations. Those are what? DXY, DYZ, DZX, DX square Y square, and DZ square. Please remember, these are the orientations of the d orbitals. Okay. XY, YZ, ZX, X square, Y square, Z square. Somebody pronouncing X square minus Y square. Don't say this X square minus Y square. It is not given like that. X square, Y square. Both are there. Okay. So now how to draw? Again, you have to draw the same pictures. Plus marks. How many you want? 5. Please the technique. Use the technique. This one. I want to take the DXY. First you will take the DXY. Means this is the X-axis. This is the Y-axis. See friends. Wow, I am drawing in between the X-axis and Y-axis. That means double dumbbell. If you are getting of the drawing skills or muggula poటీలు ఉన్నాయి అనుకోండి ఈజీగా మీరు డ్రా చేయగలుగుతారు. This is the nothing but we are having of dxy in between the x and y, in between. Previously on the x axis that is called as a px, but in between it is called as xy. Now next state is I want the yz. So friends, this is the y, already you are fixed. Now I am changing, this is a z on this one, okay. Sorry, this is not like that. This is a z axis, it is a y axis in between. Okay, the lobes are identical. I'm falsely rubbing that's what particular not identical one. Compulsory those are identical lobes will be there. This is about the dyz. Similarly, I want a dzx, gzx. This is the z axis, or you can say x axis, sir. It is a z. See what I am changing? Only direction. Cartesian coordinates are changing. Here xy. For my convenient purpose, yz. My convenient purpose, zx. So in between the lobe. This is the lobes. Okay. This is a z axis. Okay, fine. You are getting off dxy, dyz, dzx is easily. But what about the dx square y square? What is that means? That is also same thing, but that is on the x axis. This is the x. This is on the y axis. See friends, this is about the dx square y square. Now coming to the dz square, sir. Dz square. That means what happened here? The two lobes are there. This is a one lobe. One lobe is keeping on like that. Another lobe will be like that. What you are getting of? these two lobes means the dumbbell is consisting of the two lobes. This is a lobe. This is a lobe. This is a lobe. This is nothing but the dumbbell. You are keeping that this dumbbell is like that. Another dumbbell will be keeping like this. That means only this particular first lobe will be, you can see our naked eye. Second lobe, this is the back side of the your board. You can't see this particular. So you can draw that one. This is a lobe. This is a lobe. This is a front. You are keeping off like that. And the next lobe. See how I am writing this one. This is a lobe which can see our naked eye. Remaining lobe will be back side. This is nothing but what you are having. This is a only on the Z axis. Z axis. It is nothing but you are getting off this particularly called as dz square. I hope you can getting off idea regarding of this one. Okay. So what happened? One Z, one lobe. This is a dumbbell will be keeping like this. You are keeping the one dumbbell. Means first upper lobe and bottom lobe. Next one dumbbell. Next dumbbell means this is a lobe. This is a lobe. I am keeping this one. Only this front lobe will be visible to our naked. The back lobe will be back side of that one. This is called as a dz square. So this is about the d orbital shape. The 5 orientations are there, and the remaining will be, we can draw the easily. Coming to the f orbital. F orbital is complicated structure. So you can write the f orbital means it is a complicated structure. Complicated structures. But the orientations are 7 orientations are present. You can't draw in this case. This is about the orbital picture. Okay, friends. Now coming to the our area after the shapes of the orbitals, you are having of above principle. Sorry. Before that, you are having of the main important of the shapes of the orbital. Then after you writing of the electronic configuration. For the writing of the electronic configuration, requiring of the 3 principles are involved. Writing of electronic configuration of any atom in the periodic table, requiring of 3 principles. One is it can obey the above principle, Pauli's exclusion principle, and Wundt's rule. These 3 rules are obeyed by the every electron. You can arrange the electronic configuration that only. So above principle is says as like that. This is a so above is a not a scientist name. It is a German word. The word means the above means to build. To build up. Or to build, or to construct. Nirminchu. That's the meaning of that one. So above means the meaning of the to build. How the build means the says that if the electron in an atoms are available, the available orbitals, the electron is enter first. The lowest available orbitals. Lowest energy is what? The first orbit is the lowest energy state. Why? Because one quanta of energy is present. One quanta is there. In that one quanta of energy, which room is there? S room is there. That is the S orbital is there. That means the electrons are enter into the first lowest orbit. Then it will be increases to the higher orbits. That is called as above principle. Above principle is nothing but to construct means to build up. So why? Because we are constructing a house. What do you do first? You have to dig the land. That means basement. You have to construct the first basement. You are not constructing first a floor. That means roof. It is not a correct. If you are constructing the first roof means it will be collapse. First you have to dig the land, basement construction or pillar we are getting up. Then after the pillar, you can slowly the bricks, the walls are constructed. Then after a floor, that means a roof is constructed. This is the order will be there. In this case, same similar manner, the electrons are arranged in the electronic configuration according to the increasing order of their energies. Increasing order of energies, what are there? First, the electrons are entering the first orbit, that is the s orbital. Then this is the lowest energy. It will goes to the second orbit. Second orbit consisting of 2s and 2p. Next is goes to the third orbit, 3s and 3p. In the third orbit, sir, you are having of 3 rooms now, s orbital, p orbital, d orbital. But in this case, the 3s, 3p only fill. After the filling of the 3p, they enter into the 4s. Then after only 3d will be goes. Here the specific case is there. You have to remember. Why, sir? Because the 4s orbital is less energy than the 3d orbital. The energy level. Why? Because it is a rule of n plus L rule. That is rule is there. N means that you are having of the principal quantum number. L is the azimuthal quantum number rule. So that rule we are obeying this one. Why? Because here 4 s L value of how much? In this 4s means n is equal to 4. L value is 0. It is a 4 1. If 3d means C, 3 means 3 plus d value, L value is 2. Which is greater? 5 is greater. Okay, so due to that rule, 4s is enter the first electron. Next goes to the 3d. I hope you can understand this particularly. 4s means n is equal to 4. S value, L value is 0. Here 3d means n is equal to 3. D value, L d value means 2. 3 plus 2 is a 5. 4 plus 0 is a 4. So which is a lower number? 4 is a lower number. That's why the 4s orbital is enter first. Then after the 3d. Then you will go to the next. After the 3d, you are getting of the 4p. Okay. After the 4p, you are getting of what? So many are like that. You can't remember exactly. Why? Because I can write up to 6s. No problem. Why? Because you are having of the 4s, 3d. 3 shells are over. 4s, 4p also over. Next, you are getting into the 4d. Next 5s, 5p. Next 6s. Next is the 4f. This is the energy order of the above principle. How can you remember, sir? You are writing, okay, up to we know, but what about this one? So don't worry about that one. Don't worry about the increasing order of this energy levels. This is called as the increasing order of energy levels according to the above principle. I will give the one more diagram that is called as a Moiler diagram. For your understanding of this particular series, I can write again on this one. Moiler diagram, what is there? Moiler diagram. For your understanding of above principle. What is say, sir? The first floor, sir. This is the first floor. Means first orbit. Second orbit, what is there, sir? 2s and 2p. Third orbit, what is there, sir? 3s, 3p, 3d. 3 are there. Fourth orbit, what are there, sir? 4s, 4p, 4d, and 4f. Okay. And the fifth orbit, sir? 5s, 5p, 5d, 5f. Any more? The maximum orbitals are only 5. That means 4 only. F only. Like that. 6s, 6p, 6d, 6f. I'm writing all these things in our order. Okay. So friends, see. First electron is enter into the 1s. I'm writing. Next it goes to the 2s. I written. See, I using of arrow marks. 1, you have started here. The electrons are into the 1s. Then it goes to the 2s. Then it goes to the 2p, 3s. After the 2p, filling 2 means this accommodate only 2 electrons. It can accommodate 6 electrons. Next, after the 3s, 3p, 4s. After the 4s, 3d, 4p, 5s. After the 3d, 4p, 5s. After that 5p, 5s, you are getting off. What is that? After the 5s, 4d, 5p, 6s. After the 6s, what I say just now, 4f, 5d, 6p. Here you can have a 7s. So this is called as a Moiler diagram. In your manual, this is not given. Please understand this particular easiness. Why? Because I wrote the increasing order of level 1s, 2s, 2p, 3s, 3p. Then the 4s less than 3d. Next, after the 4p, okay, 4p you are getting of what? 5s, 4p. You see, 4p, 5s. Next is will go to the 4d. Next 4p over now, so it will go to 4d. So next it will go to the 5p. Next it is 6s. Next is a 4f. It is order, but this order will be, you can remember, is that not much of easiness. But by means of this Moiler diagram, you can easily understand the concept of Bohr principle, that means writing of the electronic configuration. So how to write the electronic configuration means depending on this reason only. So after the filling of all these things, lower energy levels, then only enter into the higher energy levels, the electrons will be enters. That's why keep in mind the 4s is start the first, than the particularly 3D. Near 4f, before the 4f, 6s is there. After the 6s filling only, the electrons enter into the f orbital. Because of this is a higher energy, f orbital is higher energy. You can also take this one, n plus l rule. N plus L rule. 6s means what? 6 plus 0, it is 6. 4f means 4 plus 3. 4 plus 3 means 7, which is the yes. 7 is the yes. So that it is N plus L rule also applicable for this particular principle. So Bohr principle means to construct the whatever the available electrons are, that means available orbitals are present, that particularly the electrons are entered into the lowest orbit first. Then it will goes to the higher orbits. This is the increasing order of energy level is called as a Bohr principle. Okay now. So from this particularly, already I told that Pauli exclusion principle, Bohr principle, and Wundt's rule is applicable for the writing of the electronic configuration. So you are writing the electronic configuration by means of the three principles are involved. Bohr principle is Pauli's case. Pauli's means no two electrons in an atom can have the same set of 4 identical quantum numbers. So every electron must be having the one is a spinning of clockwise, another must be anti-clockwise direction. Another we are having of the Wundt's rule. What is the Wundt's rule actually? We are saying of the Wundt's rule. It is also asking for the 5 marks question. Wundt's rule is nothing but the electrons are do not pair up first. The electrons are do not pair until the available degenerate orbital. Degenerate means here the concept is same energy levels. Which are the degenerate orbital? P orbital, d orbitals are degenerate orbital. Same energy level orbitals. The electrons are do not pair until each orbital holds at least one electron is called as Wundt's rule. Let us see the example. With the example I can explain. Carbon is the 6th atom in the electron, that is in the atomic orbital, that is a periodic table. It is 1s2, 2s2, 4 electrons is over. Next is goes to the the 2p. 2p, 2 electrons are there. I am writing the orientation. 2p having of the 3 orientation, I can write 2px, 2py, 2pz. So each electron, that means if degenerate orbitals are available, the electrons do not share until each orbital holds at least one electron. See, each orbital holds at least one electron. So it will be giving up. Do not. Why degenerate orbitals are present? If degenerate orbitals are available, the electrons are do not pair up until each orbital holds at least one electron is called as Wundt's rule. So that reason why we are getting off. This is a C. Next word go to the nitrogen 7. It is 1s2, 2s2, 2px, 2py, 2pz. Now see, one electron is there. At least one electron is holding. Now oxygen 8, 1s2, 2s2, 2px, 2py, 2pz. Means here we are having of the still 4 electrons are present. This 4 electron first we are entering into 1 1 1. Then pairing will be takes place. Pairing will be 2px2, 2px2, not 2py1, 2pz1. This pairing will be called as Wundt's rule. Okay. So friends, by means of this one, you are getting of the electronic configuration. In this examination, they will ask the electronic configuration of particularly potassium, calcium, chromium, and copper. So potassium, calcium, that is why, because there are specifically they are asking means because the electronic configuration of potassium is 19th element, calcium is 20th element, chromium is 24th element in the periodic table, and copper is 29th element. See, this is the electronic configuration you have to write. That is for the 5 marks question. They are asking the potassium. What is the 1s2, 2s2, 2p6, 3s2, 3p? What is that? 10, 12. 12 means this is the 18. Where it is entered? So according to your concept, third orbits are D. It can enter into the D orbital. But in the third shell, what is the energy order? It will goes to the 4th orbit. That is the 4s1 only. Next is the calcium. Similarly, 1s2, 2s2, p2, p6, 3s2, 3p6, 4s2, not 3d. Right, friends? Chromium. Chromium according to the normal rule. This is a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Why? Because 10, 20, 24. It is a 24. But off-filled orbital means d orbital is having of the 5 orientations. These are the 5 orientation. Here 4 electrons are present. But if a d orbital is having of 5 electron, means it is off-filled orbital, it is more stable. Due to that reason, this particular s orbital is jumped into the, that means 1 electron is jumped into the this one, 4s1 3d5. This is an exceptional case of particularly chromium. Chromium electronic, it is correct, but for the attaining of the extra stability purpose, s orbital 1 electron is jumped to the d orbital. So if you think of off-filled orbital, off-filled orbitals are more stable than the incompletely filled orbital. Due to the reason 4s1 3d5 is getting off this one. So in a similar manner, copper 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. This is a 9 means again you are having of incompletely filled orbitals. So this is a 9 element. This is a 9. Only 1 electron is there. If one more electron goes this one, it will be fulfilled. So that you are getting of that 4s1 3d10 instead of 4s2 3d9. That also you have to explain in the electronic configuration. Particularly they are asking the for 5 marks question. You have to write main important. This is the potassium, calcium, chromium, and copper. Okay. So for that, this is the atomic structure is finished. We'll enter into the 4th block. Why? Because I don't have the time to explain the gas state in the 3rd block. You are having of, you know that the gas state, what is the Boyle's law, Charles' law, Avogadro's law? Derive the ideal gas equation, derive the R values. R values you are having the 5 values are there. Then you are derive the collision molecular theory, kinetic molecular. There is nothing but a kinetic molecular theory. From that kinetic molecular theory, you are deriving the PV is equal to 1/3 mnc square. That is a kinetic gas equation. From the kinetic gas equation, you can all deduce the Boyle's, Charles, Avogadro law, and also you can the relationship with the what are the critical constant, critical temperature, and critical pressure. Then you are derive the van der Waals equation. In that van der Waals equation, what is it? Is nothing but real gas equation. What is the equation of the van der Waals? What are the applications of the van der Waals and the law of corresponding state? These are the important questions present in the gas state. But I don't suppose time permits me, I will explain. But you will go to the 4th block. Why? Because you have to attempt a minimum of 10 marks question. Na? So already 5 marks questions you have completed. Already can attempt that. So you will getting of the next 4th block. I'm supposed to start the 4th block, periodic table. You are familiar with the periodic table from your childhood words. That means in the 8th or 9th classes, this is a periodic table. What is the periodic table? Why you are studying this one means already we know that the periodic table today 120 elements are discovered. In that 120 elements, should remember all the elements and its properties. Properties means chemical and physical properties is very. You can't remember all the elements properties means it's a very difficult. So our scientists, particularly in the 16th century, Robert Boyle is our father of chemistry. 1661 Robert Boyle, he knows only 13 elements. After the 18th century, Lavoisier is a modern father of chemistry. He knows only 24 elements. In the 19th century, they know some of the Mendeleev or otherwise Newland, Deborah, and they are having of that one. In the middle of that one, they are knowing of 53 elements. So Mendeleev, he knows only 53 elements. He constructed a table, but so many defects are there. Then after in 1940s, you are having of the 91 elements are formation of naturally occurring elements, and the 17 elements are man-made elements. These are called as forced uranic elements, man-made elements. That means they are prepared in the laboratory. So these are so many number every day, means every year 1 or 2 elements are discovering. So up to now 120 elements are discovered so far. How can you remember? How can you give? So our scientists are believe that they have to arrange them in a tabular form. Why is the tabular form is if you are taking up one element, you know that one element, that element properties are something is there. You are knowing the same properties are resembles in the same vertical column. In the vertical column, whatever the elements are arranged, the properties are resemble with that one. That's why easy to understand, easy to study the periodic table, so that the periodic table is classified. So before that, starting is the de Boron triad is there. He arranged only 3 elements. It is discarded after that. Why? Because only 5 sets is arranged. So many elements are after discovered. So it is not applicable for the all the elements for the de Boron triad. Next, Newland octave. Newland octave is he arranged the elements in the according to the increasing order of atomic weight, continuously written like that. According to the increasing order of atomic weights is written hydrogen, lithium, like that. Beryllium, boron, carbon, nitrogen. This is a written as. He says that first element is resembled with the 8th element. That's why it is called as octave. Octave means 8. Newland octave means first element is resembling with the 8th element. Why it is taken as 8th elements? Again, our Indian musical system is there. Sari Gama Padanisa. These are the words are 8 only. Sa, Ri, Ga, Ma, Pa, Da, Ni, Sa. Again, you are getting of Sa. That is repeated word. So here also he is applicable. That particular Newland octave is nothing but Sarigama Padnisa means Sa means first letter, first element. The 8th element, same pronunciation we are getting. So it will be resembles the first element with the 8th element. But it is also discarded. Its defects are there. Why? Because after the calcium, the rule is not applicable. After the calcium, it is not applicable. At the time of Newland octave, noble gas elements also not discovered. After the discovering of, it is not kept a place. Then after Mendeleev is put for the table, he constructed a tabular form. He arranged the elements into 8 groups and 7 periods. The 8 groups are Roman letters. They are arranged and also they are subdivided to A and B, 8 groups, and periods are 7. But the advantage of the Mendeleev is he is kept place for the unknowing elements. He leave the boxes leaves for the unknown elements. That is the future purpose. He kept the unknown purpose, the leave the box. That is called as Eka. He says the Eka means is a Sanskrit word 1. Eka boron. Eka aluminium, Eka gallium, he says. Eka boron at the time he says now today it is a scandium. Eka aluminium, it is a gallium. Eka silicon, now it is a germanium. That is about the Mendeleev theory. Then Mendeleev theory, then we are entered into the modern periodic table. See, this all the theories put forward according to the increasing order of atomic weights only. Increasing order of atomic. That means the help of atomic weights they are arranged. But in the Mendeleev, the defect is there. Some of the atomic weights are less is there, not the increasing order. So atomic weight will not take in the modern periodic table. It says the elements are arranged according to the electronic configuration. Electronic configuration is nothing but atomic number. The physical and chemical properties of atoms of their elements, their increasing or according to the electronic configuration is arranged. That is called as a modern periodic table. Modern periodic table is nothing but you are saying of that one, particularly the elements are arranged in the increasing order of their atomic number. The elements are arranged in the increasing order of their atomic number. Atomic number nothing but electronic configuration is called as modern periodic table. Today the modern periodic table is classified into 18 groups and 7 periods. What do you groups are? Groups are nothing but vertical columns are called as groups, and horizontal rows are called as a period. So groups and periods are classified. The modern periodic table is classified into groups and periods. Now today in the modern periodic table we are having of the 18 groups are there and 7 periods are there. So I will show that periodic table. Yes, this is the periodic table. We see that one, this periodic table. I hope you can understand easily. Actually, the chart is not there. So I draw this particularly periodic table. See, this is the groups. The vertical columns are called as the groups. Okay, friends. So these vertical columns, nothing but these are the groups. First group, second group, like that. How many are there? 18 groups are there. But previously it is written as in the Mendeleev Roman letters 1, 2, 3, 4, 5, 6, 7, 8. This is 8 is the 0 group element. It is divided into subblock. That means subdivided. A, B are there. Okay. Now the horizontal rows. These are the horizontal rows are called as the periods. 7 periods are there. 1, 2, 3, 4. 7 periods are there. 18 groups are there. So modern periodic table is arranged in the 18 groups and 7 periods. See friends, in this particular case, how the elements are arranged. The first A and second A group belongs to the S block elements. S block elements. Why it is called as S block elements? I will again explain. Why? Because the differentiating electron is entered into the S block. That's why these S block elements are called as, that means the last electron is entered into the which orbit, that is belongs to that block only. So first year group elements and second year group elements are belongs to S block. Already we know that in the first block, our block unit, one first unit and second unit is belongs to this only. Hydrogen, lithium, sodium, potassium, rubidium, and cesium. These are the beryllium, magnesium, calcium, strontium, barium, and radium are belongs to the first and second A group element. Those are called as S block elements. Coming to the 13 to 18 means third A to 0 group. These are belongs to the P block element. Why it is called as a P block element? The differentiating electron is entered into the P block. The last electron is entered into the P block only. That's why this is called as a P block elements. Now in coming to the, these are in between 3rd to 12. These are called as D block elements. Why it is D block element? The differentiating electron is entered into the D block. Scandium to zinc. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. These are the 3D group. 4D, 5D, 6D. I incomplete. I will give kept as like this. This is a old modern W. Remaining elements are newly discovered one. Okay. These are the newly discovered. Whatever the spaces are available in that. These are the D block elements. D block elements is also called as a transition. Why? Because in between S and P, in between the block, the elements are arranged. That's why it is called as transition. Transition meaning is in between. So you say that SSC intermediate degree. Intermediate means in between stage. That is intermediate stage is in between stage. If you are perfect in that studies, you can go to the degree, or you can, something is happened in the intermediate means you will come back to the SSC. That is the case of intermediate student. Why? Because intermediate stage is a puberty stage. The students can't listen the lectures wise or in the parents also. They can say, I know everything. Why? Because at the time, the puberty stage, the hormones will be releases. You can't listen your elders' voice. I know everything, you can feel as. But the thing is, you can do some mistakes. Due to other mistakes, you can't reach your goals. That is the problem of this particular intermediate means transition. If transition occurs, you will go to the whatever you want. You can achieve your goals. That means it is called as a transition elements. Now coming to the in this third B group element, scandium, yttrium, lanthanum, actinium. At the lanthanum, the 14 elements are arranged. That means cerium to lutetium. Cerium to lutetium is called as a 4F block elements. That will be placed in the third B group elements only. That means third group. But I don't have the 14 elements arranged in the one place. So I am keeping on the bottom of the periodic table. Similar manner, actinium. From at the actinium, whatever the thorium to lawrencium, 14 elements were, I have to fix here. So there is no place. I am keeping bottom of the periodic table. That's why it is called as actinides. See, lanthanides, actinides. Lanthanides, 4F series, actinides, 5F series. These two series are called as inner transition elements. The two series are called as inner transition elements. See friends, here S block, P block, D block and F block elements are arranged so that your modern periodic table is divided into 18 groups and 7 periods. In that 18 groups and 7 periods, you are classified into the according to differentiating electron. You are classified into S block, P block, D block and F block elements. Okay. So here see this particular first, whatever the number of groups are there. The first group elements are called as alkali metals. Already told I told in the first unit. Second group elements are called as alkaline earth metals. Why? You already known the reason. The last extremely right in the extremely right side of the periodic table, the last group is nothing but it is called as a zero group element. It is called as a noble gas elements. It is also called as inert gas element. It is also called as rare gas elements. So many number of names are there. Zero group, noble gas, inert gas, rare gas. Why, sir? So many reasons are there. I will explain that one. These are called as a noble gas or zero group element. Now coming to the next. This is a fluorine, chlorine, bromine, iodine, astatine. That is the 7th group or 17th group. It is called as halogens. Halogens. That means C made elements. All are present in the sea. That means minerals only. That means in the sea water. Next halogen. Oxygen, sulfur, selenium, tellurium, and polonium is there. These are called as chalcogens. In the examination point of view, these are asking. First group are called as alkaline. Second group is called as alkaline earth metals. 18th group is called as noble gas or zero group or inert gas or rare gas. And 17th group is called as halogens. And 16th group is called as a chalcogens. Sir, what happened this one? This is nitrogen family. This is carbon family, boron family. Nothing is there. So if you want to ask me, 15th group means it is a nitrogen family. If the 14th group means it is a carbon family. 13th group is called as a boron family. Okay, you have to remember. Now coming to this one, that the black elements 3, 4, 5, 6, 7, 8, 9, 11. But the Roman letters 3rd B, 4th B, 5th B, 6th B, 7th B, 8th B. 8th group is 3 groups are there that belongs to the 8 only. Next, after the 8, immediately first B. Next, second B. Second B elements are nothing but zinc, cadmium, mercury. These are the D black elements. But the first group element, copper, silver, arum. Copper is the precious, silver is the precious, and also arum, that is the gold is the precious. These are nothing but kinase elements. Why their first B group elements are called as kinase metals? Why? Because they are prepared, that means used for the coins, making of the coins, copper coins, silver coins, gold coins. So this is called as a kinase metals. D block elements, all D block elements are metals, pure hard metals, and also they show the color property. They show the paramagnetic in nature. The magnetic color is there. Okay, and also their variable oxidation states are there. S and P black elements are here. See, these S black elements are metals. P black elements are metals are there. Non-metals are there. Not metalloids are there. These are all are, but they are not having of the color property. And you are also see that particular 4F black, 5F series. 5F particular octanates are radioactive elements. All are radioactive elements. Everyone from thorium to polonium, uranium, neptunium, plutonium, americium, like that, everyone is the radioactive nature. They are man-made elements. After the 93 element, that means 92 is the uranium. After the 93, whatever the elements are which are present, that means those are prepared in the laboratory only. And here see the name of the particular elements are honor of the scientist names only. Einsteinium, fermium, mendelevium. See, Einsteinium ES, fermium FM, mendelevium. Mendel is prepared the construction of the table. That's why they are honor the keeping of this particular element's name also. This is about the periodic table, major periodic table. In this case, they ask the number of questions in the multiple choice question. Coming to the long questions. Long questions, what is modern periodic table? How the elements are classified according to the differentiating electron. So what is modern periodic table? The elements are arranged in the increasing order of atomic number is called as modern periodic table. Now the next classification. The classification based on the differentiating electron. Differentiating means the last electron enter into which orbit. On the basis you are differentiating the elements. All the periodic 120 elements are arranged or classified into how many blocks? 4. S block elements, P block elements, D block element, S block element. What are the S block elements? Already you know that. First A and second A are 1, 2 blocks groups are called as S block elements. These S block elements are electronic configuration is first group electronic configuration is what? NS1. Second group electronic configuration is NS2. That means S block elements electronic configuration varies from NS1 to NS2. See, simple. It is over one group. Next, coming to the P block elements. The P block elements are present from 13 to 18 or 38 to 0 group element. These are called as a P block element because the last electron is entered into the P orbital. That's why these are called as a P block element. The P block elements general electronic configuration. This is the third, means what is the third A group elements, or you can say 13 group. It is NS2, NP1. If you take the 0 group element, I'm taking off 0. 0 group means 18th group. What is the electronic configuration? NS2, NP6 means NS2, NP1 to NS2. This is a NP2, NP3, NP4, NP5, NP6. The electronic configuration is varies in the P block elements. P block elements from NS2, NP1 to NS2, NP6. Totally 8 electrons are present. This is the octet. 8 electrons. This is the called as a P block element. P block elements are from 3rd to 0 group. So what differentiate? Now coming to the D block elements. What do you mean by D block elements? The last electron is entered into the D orbital. That is called as D block element. The D block elements, the general electronic configuration. I'm writing general electronic configuration of D block. D block element general electronic configuration GEC. So this is nothing but NS2 N-1 D1 to 10. This is a general electronic configuration of D block element. NS2, sir. If you see the scandium is the 21st element. What are you writing? Argon, I'm short form 4s2 3d1. Okay. Zinc, 30th element. Argon means 18 electrons. These are the 18 electrons finished. 20, 21. So argon 4s2 3d10. This is zinc. Scandium to zinc. I am writing the electronic configuration. This means the electronic configuration, general electronic configuration of D block element NS2. N means this is a 4s2. 4s2. 3D means N-1. That is nothing but the 3D. It is called as a N-1 means it is 3. N is called 4 you are keeping. This is a 4 minus 1 means 3D. 1 to 10. 1 to 10. This is a general electronic configuration. The 4D D block elements are, they are classified into 3D, 4D, 5D and 6D. Every block 10 elements are present. It is incomplete, but today it is filled with the 10 element. Why? Because newly discovered elements are there. Previously in your book it is called as an incomplete D block 6D. You are having of 3D, it consisting of 10 elements. 4D, it consisting of 10 elements. 5D, 10 elements. 6D, it is a incomplete one. It is an incomplete one is there, but today is a 10 elements. Total 40 elements are belongs to the D block elements. These D block elements are, that is a differentiating. So like that you have to write. Next, coming to the F block elements. The F block elements, the general electronic configuration. The general electronic configuration of F block elements is C. Please remember this NS2, N-2, F1 to 14 and N-1, D1 or sometimes 0 also. 1 or 0. This is a general electronic configuration of F block element. These F block elements are classified into 4F series and 5F series. 4F series is called as the lanthanides. 4F series is called as the lanthanides. 5F series is called as the actinides. Okay. So friends, the F block element, general electronic configuration, why it is called as F block means the last electron is enter into the F orbital. Those are called as, and F block elements are belongs to which group? They are asking it particularly. F block elements are belongs to third B group. These are belongs to third B group element. Nothing but third group. In the numerical, particularly Arabic letters, third Roman letter, third B. See, this is the third B. Why? Because on the lanthanum there is no place for the 14 element. Why? Because 4F element, 4F series is consisting of 14 element, 5F series consisting of 14 element. 28 elements total F block elements are there. They are not keeping at the lanthanum and actinium. So you are keeping at the bottom of the periodic table. That's why this is a belongs to which group is third B or third group elements. This is about the lanthanides and actinides. This is about the differentiating electron you are classifying. One more question on the same question is asking. How the elements are classified according to the chemical properties and electronic configuration. Sometimes they ask the chemical properties, or sometimes they ask the electronic configuration. According to the electronic configuration or chemical properties, the periodic table 120 elements are classified into again the 5 categories. What are the representative elements? Representative elements, noble gas elements, transition elements, inner transition elements. See friends, again the 4 only. There is the SPDF is there. SPDF, why it is called as? Because of differentiating last electron. Here what is said, according to the chemical properties or according to the incompletely share valency electrons. Incomplete means totally not completed. Those are called as, again, the classified into noble gas elements, representative elements, transition elements, inner transition elements. What is the noble gas elements, sir? This is only the one key. Only 0 group elements. Only 0 group elements. So noble gas elements are 18 group or 0 group. These are called as noble. Or it is as inert gas. or it called as zero group, or it called as rare gas. These are all are the name belongs to which group? 18 group or zero group. These are called as noble gas. What are those? Helium, neon, argon, krypton, and xenon. Helium, neon, argon, krypton, xenon, and radon. These are the, what is the electronic configuration of all this? This all are nothing but NS2, NP6. They are completely filled electrons. 8 electrons are present in the outermost electronic configuration. 1, 2 plus 6, 8 electrons are there. If the atom is having of 8 electrons, that is octane. Octave is completed. Those are stable elements. So noble gases are monoatomic in nature. They are existing in the atmosphere monoatomic state, and they do not combine with any other element. They are existing in a monoatomic state only. So these are the stable. Noble means they are the precious which are present in the atmosphere. Inert means they do not chemically react each other. Inertness. Zero means the valence is zero. Due to the valence there means valency means what? Combining capacity. They do not combine with any other elements. That's why zero valency. Rare gases means they are present in the rare only, which are present in the very minute fraction in the atmosphere. Very minute fraction, except argon. Argon is 0.9% is present in the atmosphere. Remaining are very fraction amount is present in the atmosphere. That's why it is called as the rare gas element. This is about the classification of the noble gas. First is the noble gas elements. Next is the representative elements. What do you mean by the representative elements? Means S and P block. Second classification is representative. First classification noble gas. Representative elements. What do you mean by there is a representative? Means S and P except zero. You are excluding the zero group. Called as P block elements. That is a representative. See, S 1, 9, 2, 3, 4, 13, 14, 15, 16, 17. These are called as representative elements. S and P except zero group will called as a representative element. The electronic configuration is various representative NS2 to NS1 to NS2 NP5 only. This is the 17th group or 7th A group element halogens. The representative elements is the nothing but the, see, these are the chemical properties differ well which is compared to the this one zero group element. These zero group elements are stable compounds. They do not react anybody. They are monoatomic nature. They are rare gases. They are noble gases. Zero valence is there. But here the representative element they represent. Why? Because the first group element lithium is reacted with the chlorine. Lithium chloride salt is formed. Sodium is reacted with the chlorine, sodium chloride. Sodium is reacted with bromine, sodium bromide. Sodium is reacted with iodine, sodium iodide. Potassium is reacted with the chlorine, potassium chloride. Potassium is reacted with fluorine, potassium fluoride. Like that, the salts, whatever the barium is reacted with the chlorine, barium chloride. First to second group is reacted with the seventh group elements. The reaction is there. The sharing or gaining of the electrons takes place. Once atom is losing the electron, another atom gains the electron. In between the bond is formed. That is called as ionic bond. Mutual sharing of the electron is called as a covalent bond. Mutual sharing means hydrogen. Hydrogen can form hydrogen molecule. Oxygen molecule. Like that, this is a representative elements are present. So these representative element means S and P block except zero group is called as a representative elements. Next, transition element. Third is the transition element. See, why you are studying the transition already told that in between transition elements. See friends, here what I am saying from 3rd to 12 is D block elements. But here 3rd to 11 only called as third to 11 only called as a transition. The 12th zinc, cadmium, mercury is not a transition element. Please remember. I want to classify this particularly incompletely filled valency. Valency electrons are not completely filled. Those are called as electronic configuration. We are classifying the transition element. Transition elements means 3 to 11 means up to copper, silver, arum. That means there only. That means the electronic configuration is NS2, N-1, D 1 to 9 only, not 1 to 10. If 1 to 10 means it is called as a D block. 1 to 9 means it is called as a transition elements only. These are called as a transition elements. Transition elements are nothing but these are the elements which are having of hard metals. All are hard metals. Color property, magnetic property, they can form the complex, and also they are good catalysts. See, catalysts are, you are having of the nickel, palladium, platinum. You are using the catalysts which are using the chemical properties. Nickel catalyst, palladium catalyst, platinum catalyst. Very beautiful. And tungsten is the highest boiling point. Tungsten, this is a wolframite. W is a wolframite. Tungsten is a filament which is present in the bulb. Why? Because the melting point is almost all 3200 degrees Celsius. 3200 degrees Celsius melting point is there. That's why it is hard metals. So all our metals are present. These are the transition elements. Next, fourth is inner transition elements. Inner transition, why it is called as the inner transition? Because the elements are present in transition group only. This is a transition element. In between lanthanum, in the actinium, these elements are present. That's why it is called as an inner transition. Transition lo lopada undali. But this is a inner transition elements. So inner transition elements are 4F series and 5F series. That means lanthanides and actinides are called as F block elements. What is the general electronic configuration? If you see the 4F and 5F series, this is nothing but NS2 and N-2F1 to 13 only, not total full 14, and N-1 E1 only, not any other, one only. This is the general electronic configuration of inner transition element. Inner transition elements also metals, particularly 4-5F series are all are radioactive elements. Radioactive element means spontaneously emission of alpha, beta, gamma rays. There is dangerous one. Okay, so 4F series and 5F series. These are not radioactive elements. There are radioactive elements. The oxidation state is +3 and +4. These are +3, +4, +5 also sometimes. This is about your second sem. You are having of D block and F block elements are there. That is the important of the second sem. So this is about the inner transition. So like that you are classified. 2 essay type questions are over. According to differentiated electron, 1 essay type SPDF, according to the chemical properties or electronic configuration or incompletely balanced shell. These are classified into 4 categories: noble gas, representative, transition, inner transition. Okay, friends. Now we'll go to the properties. Properties are why? Because so many number of properties are there. Particularly the whatever the properties, I will finish up within 5 to 10 minutes. The properties are very important. Again, the long question of this particularly in the periodic table, the properties. Periodic properties. What are the periodic properties? First is atomic radii. Atomic radii. What is the meaning of atomic radii? Means simply I will see that one. This is a nucleus. It is orbits. It is orbit like that. So there means here from the nucleus to outer orbit. That means this electron is present. This is called as a radius. Atomic radius is nothing but from nucleus to where the last electron is present. The distance between the nucleus to the last electron. The distance between the nucleus to the last electron is called as atomic radii. Okay, friends, that is the definition. What is the trends they are asking particularly? What is the trend in the examination? If it's a 10 marks question, you have tried the properties, they will ask the 3 properties: atomic radii, ionization potential, electron affinity. First, you have to define the atomic radii. What do you mean by that one? The distance between the nucleus to the last electron is called as atomic radii. What is the trends in the groups? If you are going to the group means it is a vertical column. Period means horizontal row. It is a horizontal row. This is a period. So what is the trend in the group? See, in the group, first group, from the lithium to francium, what happened? Atomic number is increases. Atomic number is increasing as well as the number of shells are increases. See, 7. You are having of 6, 7. Cesium. This is the cesium. Or francium is the 7th element. That means the 7s1. So what is the C? Lithium is having of, lithium is 1s2. Okay, friends. 2s1. This is a C here having of 1s2, 2s1. This is the second element. The radius is atomic radius. From the lithium, atomic radius is from nucleus to this one. This is the size. Francium is the atomic radius is this much of size. What happened? From lithium to francium, the size is, the group size is increases. Are you following this one or not? Atomic radius means in the groups number of shells are increases. Due to increasing of number of cells means automatically the distance is increases from the nucleus. If it's an increasing of nucleus means radius also increases. So from the top to bottom in the groups atomic radii is increases. Coming to the periods. Now the period I am taking the second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This is the second period. In the second period what happened? This is a 2s2. This is a 1s2, 2s1, 1s2, 2s2, 1s2, 2s2, 2p1, 2p2, 2p3. That means it will be only the electrons. The first orbit, only second orbit. But here in the group, the orbits are increases. But here in this period, orbits are not increases. The orbits are not increases. It is a what happened? But number of electrons are increases. Here 2s2. Okay, 2s1, 2s2, 2s2, 2p1, 2s2, 2p2, 2s2, 2p3. Number of electrons. Here 2 electrons are there. 2 electrons, like that. Number of electrons are increases in the second orbit only. If the number of electrons are increases, what happened? Nuclear attraction force is increases. So they come very close. If electrons are coming closer compared to this one, then you will compare this one. So number of electrons are increases means nuclear attraction force is increases. They are very close. That's why the size is decreases from left to right. Why the size is decreases or atomic radii is decreases? Because electrons are increases. If the electrons are increases means nuclear attraction force is increases. If nuclear attraction force is increases means that electrons are come very close to its nucleus. Like that initially is there. Number of electrons are increasing slowly, they come closer. Those atomic radii is decreases from left to right in the period. But in the group, the atomic size is increases from top to bottom. That you have to remember in the case of properties. The first property is over. Next, coming to the second property, ionization potential. Ionization potential. It is called as IP. What is ionization potential means? Nothing but in an atom, the loosely held electron we have to remove. The amount of energy required to remove one electron. Which electron? Loosely held electron, not all electrons. The amount of energy required to remove loosely held electron in an atom is called as ionization potential. Sir, if you know that one, there are beautiful example of sodium 11th atom in the periodic table. 1s2, 2s2, 2p6, 3s1. The last shell, which how many number of electrons are there? Last shell means third orbit. 1 electron is present. But the stability purpose, an atom are requiring of 8 electrons. Here the sodium is having only 1 electron. It requires 7 more electrons is required to getting of stability. 7 electron gaining is easy, or 1 electron to lose the easy means 1 electron is losing the easy. See here, ionization potential means the amount of energy required to remove the loosely held electron from its outermost shell is called as ionization potential. So sodium in the outermost shell, 1 electron is there. It loses 1 electron. So it is losing. So getting off 8 electrons, 2s2, 2p6, 2s2, 2p6 means 8 electrons. That means it is nothing but taking off ionization potential is like that. 1 electron means metal. Sodium is a metal. Energy. What energy required? Ionization potential. Amount of energy required. Why? Because you are not giving freely. I am giving off 1 chocolate. Please give me the chocolate. That means if you are giving 1 pen is there. Person is having off. You are not having the pen. What he says? He won't give. But you are. What happened? You are giving the. I will give the chocolate now. We will give the pen for a few minutes. Immediately they will give. Or sometimes if you have extra means I will take the biryani. I will give. You will give something or notes or whatever it may be. This is why because you required whatever one. So easily not give that one. This particular metal loses the electron means requiring of some energy. So that you are getting off. This is the reaction M plus 1 electron is loses. We are getting off metal ion. This is the formation of metal ion. This energy is called as ionization potential Ip1. Okay, Ip1 means only from the initial isolated atom or metal, one electron is loses. Same M plus ion. Already one electron loses by one. You can removing one more electron. That is energy. So M plus 2, one electron is loses. See friends here, this is called as Ip2. Second, again I am removing one more electron from that atom. Firstly, I am removed one electron. It is called as a M plus ion. From M plus ion, I can take one more electron. See, already sodium is example like given as 11, 1s2, 2s2, 2p6, 3s1. I am removed the one 3s1. The energy is very less. Why? Because only one electron is present in the last shell. But from the sodium place is one rooming. From the sodium place means 2s2, 2p6. It is a very stable one. Octet rule. I want to remove one more electron. It's possible, but requiring of large amount of energy is required. Very large. Why? Because already 8 electrons are there. They are stable form. Due to the stable form, you are removing one more electron means requiring of some more energy. Not easily means you are only from the chocolate they won't give. They will give the biryani. Means this is see the cost. Chocolate means 1 rupee. Biryani means 200. That is the difference. That means that much of energy is required to remove this electron from M plus ion. That's why Ip2 or higher Ip, that means Ip2 is always greater than Ip1. So it is also asking your examination. Ip2 is always greater than Ip1. They are asking why? Because more amount of energy is required to remove the already removed atom. So this is about the ionization potential. Ionization potential means the amount of energy required to remove the electron from loosely held electron is called as ionization potential. The second ionization potential or higher ionization potentials are always greater than lower ionization potentials. That you have to keep in mind. That is about the ionization potential. And the third property, electron affinity. Electron affinity. This is called as EA. Electron affinity. What is the electron affinity means? Simply, first ionization potential, amount of energy required to remove. That is a removing purpose. Now you are adding the electron. For that purpose, adding the electron means the energy, the amount of energy released when an electron is added to the isolated neutral atom. The amount of energy released here, there is required. The amount of energy released when an electron is added to the isolated neutral atom. దేనికి యాడ్ చేస్తున్నామట? తటస్థ పరమాణువుకు ఒక ఎలక్ట్రాన్ ను మనము యాడ్ చేస్తే ఎంతైతే శక్తిని విడుదల చేస్తుందో, రిలీజింగ్ చేస్తుంది, విడుదల చేస్తుంది, రిక్వైర్డ్ కాదు. అక్కడ రిక్వైర్డ్ ఐనైజేషన్ పొటెన్షియల్ కు ఒక ఎలక్ట్రాన్ ను తొలగించడానికి కావాల్సిన శక్తినేమో ఐనైజేషన్ పొటెన్షియల్ అన్నాం. ఇక్కడ ఏమంటున్నాము? ఒక ఎలక్ట్రాన్ ను జత చేయడానికి, యాడ్ చేయడానికి, కలపడానికి, ఒక ఎలక్ట్రాన్ కలపడానికి ఆ తటస్థ పరమాణు కలిపితే కొంచెం శక్తిని విడుదల చేస్తుంది. ఆ విడుదల అయ్యే శక్తిని రిలీజ్ ఎనర్జీ ఈజ్ కాల్డ్ యాజ్ ఎలక్ట్రాన్ ఎఫినిటీ. The amount of energy released when an electron is added to the neutral isolated atom is called as electron affinity. So that is nothing but X is a neutral atom. You are adding of one electron. You are adding. So formation of X minus. See, akkada cation erpadadi, ikkada anion erpadadi. Next, energy is removed. This energy is called as electron affinity. What happened? Energy is removing. Removing of the electron is called as electron affinity. Okay? तटस्थ परमाणु को इलेक्ट्रॉन कलपड़म. You are adding. क्या हुआ? जैसे a neutral atom को one electron add करे तो वो क्या हो रहा होगा? That is giving off some energy. Nothing but we are taking off. What happened in the morning is a very hot biryani you took in your stomach. Immediately what happened? You are getting off sweat. How is the sweat is coming? Because of the energy will be released out. You are doing up. That is a burning will be take place. There is a energy releasing. So that is called as electron affinity. Okay. So friends, the electron affinity means this is the case. What is a loosely held electron is held in this one. So in this case, ionization potential and electron affinity in the groups. What are the periods? What happened this one? See here in the groups. What happened from this one? It is a 7s1. It is a 2s1. Can you remove the electron from 2s1 is easy or 7s1 is easy? I will give the example. I am here. Yeah, the 7 students are there. I can catch all the students like this. How many students I can catch? 2 or 3 members. I tightly catch. What about the last student? Easily jump out. Easy ga? That means energy is amount of energy required to remove that particular last student means very less. That means in the group the ionization potential values are decreases. But ikkada pattukunnanu first student pattukunnanu vani పరిగెత్తమంటే పరిగెత్తాడు వాడు బాగా పోట్లాడతాడు అంటే ఎనర్జీ ఎంత కావాలి చాలా కావాలి ఆ ఎలక్ట్రాన్ అది తొలగించాలంటే ఎలక్ట్రాన్ సో ఇన్ ద ఫస్ట్ ఇట్ విల్ బి ఇంక్రీజ్ నెక్స్ట్ గోస్ టు ద ఫ్రమ్ టాప్ టు బాటమ్ ఇట్ ఈస్ a decreasing. So ionization potential from the in the group from top to bottom decreases, but in the case of the period ionization potential is increases. Why? The electrons are very close to me. I can't give, but you are required the electron. So what is the case? Sir, please, we are begging like that means the energy is more. So that in the period the ionization potential is increases. From left to right ionization potential is increases in the period. From top to bottom in the group ionization potential is decreases. Similar manner electron affinity, adding of electron in the last shell easy na, you can add it. అక్కడ కలుపుకో నాకేం పర్లేదు అటు దూరంగా ఉన్నాడు అని చెప్పేస్తున్నాం. See in the electron affinity groups it is easily so that it is in the groups it is decreases from top to bottom, but the period if the chlorine is there 7 already the electrons are ns2np5. Adding of electron means it is a very difficult, you are getting of this one particularly. So in the period it is also increases. See, this is a case we have to study the electron affinity. So in the groups from top to bottom it is a ionization electron affinity is decreases. In the period from left to right the whatever the electron affinity is increases. Okay, the last property electronegativity. Last property is the fourth property, electronegativity. What En it is called as? Electronegativity is called as En, electronegativity. Okay, what is the electronegativity definition? The ability to attract the what is the shared pair of electron towards itself. Electronegativity అంటే ఏం లేదమ్మా, అట్రాక్షన్ ఎబిలిటీ ఉండాలి. ఎట్లా చూద్దాం. నేను ఇంతకు ముందు చెప్పాను పీరియాడిక్ టేబుల్లో highest electronegativity atom is fluorine. Highest electronegativity atom among the 120 elements, fluorine is the highest. This ability, why? HF, hydrofluoric acid, the ability to attraction of the electron towards itself, that is called as electronegativity. So the fluorine can attracting as what you are getting of HF, hydrofluoric acid. HCl, chlorine, this attraction will be takes place. Okay, KCl, sodium chloride, this is ability to attract the other atoms or paired shared pair of paired electron. Paired electron means it is an atom. Attraction will be takes, so that this is called as the ability to attract the shared pair of electron towards itself is called as electronegativity. Electronegativity same it is manner in the whatever the groups and periods. In the groups the electronegativity from top to bottom it is decreases. Highest electropositive element is cesium in the periodic table. Highest electropositive is cesium. Highest electronegativity in the periodic table is fluorine. If the fluorine is having of the fluorine is the electronegativity is 4. Next we are having the oxygen is 3.5 the electronegativity. Next is the nitrogen is a 3 electronegativity. Next is the carbon is having of 2.5. Next is the boron, it is having of electronegativity is 2. Next is the beryllium, it is having of electronegativity 5. Next is the lithium, it is electronegativity is 1. How can I remember? See the equation either 1, 1.52, 2.53, 3.54. Easily to remember this one. That's why I remember the values. Only 0.5 is difference is there for every atom in the period. So in the period, what happened? Electronegativity is increases from left to right. From the left to right in the period, the electronegativity increases. So that's why fluorine is the highest electronegativity atom. Whatever the zero group elements are, there is no electronegativity. Why? Because there is no ability to attraction of the elements. Zero group elements are inertness. They do not chemically react each other. But high ionization potential. Among all the elements in the periodic table, zero group elements are possessing high ionization potential. High ionization potential means remove the electron is very, very hard. Why? Because it is NS2 NP6, sir. Octet rule, sir. Can you take the electron from the octet rule, sir? It is very impossible. Biryani, nai. Do biryani, nai. Panch biryani, nai. 1 month I can take the total. Then only it can just bend. That much of energy required. So this is the noble gas elements are high ionization potential in the periodic table. High electronegativity is a fluorine. This is the so in the groups electronegativity is decreases. In the period that is negativity is increases. So you can remember this is particularly the trends in the periodic table. I will write the
Sir, at level 30 we have max class.
Particularly size, that means atomic radii, ionization potential, affinity, electronegativity. Okay, friends, I am writing down in the groups, in the periods. In the groups means I can write top to bottom. Top to bottom means group. Right to left. Why? Because I'm just insisting. So many students are writing in the periods, top to bottom. They are writing. Top to bottom is not there in the periods. In the groups, right to left, it is not there in the right to left. Only the vertical column. It is a horizontal row. So in the groups, top to bottom, atomic radii is increases. It is decreases. Once you know that one, it is opposite. It is decreases. It is increases. It is decreases. It is increases. See friends, it is decreases. It is increases. Once you know the table form, you can write all the properties very easily. Atomic radii increase. Why? Because number of shells are increases. So the size is increases. Here, same electrons in the second orbit only. In the second period you take. So it decreases. If you remove the electron from the last shell, very easy. Oof, monoto electron jate. But you can remove the electron from the second orbit. No chance. Chocolate nahi, biryani nahi, dusra hona. So this is again electron affinity. Adding of electron from the last shell it decreases. Why? Because add karo wahan pe hai na. Very easy. The energy will be liberating energy. It is very less. But adding of electron in the second shell, some more energy required more. Releasing of energy is more. Electron negativity, ability to attract the electrons in the groups, it is decreases. Why? Because the last one, lithium or francium. Francium is radioactive element. Of course, cesium chloride, very easy to attract. Compared to that, if you are going down fluorine attraction. See, difficult. That it will be increases. Same atoms we are using in the period from left to right. This you know that one you will getting of the remitted idea. Okay, this is about the long question from this. That means we are having the 3 long questions are over. One is the differentiating electron. Next is the classification of elements on the basis of chemical properties or valency electrons or electronic configuration. Next is the properties, these properties, and one more is there. What are the factors influencing of ionization potential? These are the important question for the long question. What are the factors influencing? Why? Because the factors also present influencing of the electron, that is ionization potential. Mainly important, the factors are influencing of ionization potential is nuclear charge, atomic size, screening effect, penetrating power, and stable electronic configuration. These are the 5 factors are influencing of ionization potential values. Nuclear charge means charge is more means very charge is more means you can remove the electron is very tough. Ionization potential increases. Okay. Next is the atomic size. Size is more means it is easily removed. Ionization potential decreases. Next, screening effect. Screens are there. Inner shells are act as a screens. Screening is there. Screening means there is a different. There are attraction towards the nucleus. The screens are remaining electrons are free is there. We can remove easily. Ionization potential decreases. Penetrating power. The penetrating power is. I can explain the penetrating power with the help of S is the more penetrating power. It means this is the nucleus. Here, this is called as a F orbital. This is called as a D orbital. This is called as a P orbital. It is called as a S orbital. See, friends, penetrating power. I am using of penetrating power, which is having of more penetrating power. See, S orbital is very close to the nucleus. So S orbital is having of more penetrating power than the P orbital, than the D orbital, than the F orbital. That means you have to remove the electron from the S orbital, not that much of easy than the P orbital, than the D orbital, than the F orbital. F orbital, you can easily remove that one. And stable electronic configuration means NS2, NP6 is there. Noble gas elements are. You can't remove the electron from that one. That's why it is the highest ionization potential. These are the factors influencing of the ionization potential. See, 5 are there. Nuclear charge, atomic radii, screening effect, penetrating power, and stable electronic configuration. You have to write all the 5 things in the influencing of the factors on the ionization potential. That is a long question. Again, the short bits are there. You are knowing of diagonal relationship. It's a lanthanide contraction. Diagonal relationship, already I told that in the very first class. What is that? The first element of the first period is resemble with the second element of the second period. Second element of the second period is called as a diagonal relationship. That is nothing but I write that lithium, beryllium, boron, like that. Next is the lithium. It is a you are having of sodium, magnesium. Okay. Next boron. That is after the boron you are having of aluminium, carbon, silicon, like that. This lithium is resemble with the magnesium. Beryllium is resemble with the aluminium. This is called as a diagonal relationship.
Sir, time
First element in the first period is resemble with the second
టైం అయిపోతే నువ్వు వెళ్ళు క్లాస్ కి వినేవాళ్ళు వింటారు కదా.
Diagonal relationship. Okay, ma? Right. This is about the periodic table. From these 4 questions are explained.
Sir, time అయిపోయింది sir.
Examination. By this already time is up. Okay. So remaining things will be I can use in the WhatsApp group. I will give the whatever the assurance is given for every chapter wise important questions. I can send in the WhatsApp group every chapter wise important questions. And if you are having of any doubts in this particular cases, why? Because it is a today is the last class for us, and whatever the you are listen, please read out, go through that one. You will getting of all 80 marks. What my intention is to covering of total 80 marks question. Okay, right friends, I'm leaving the class. Why? Because already classes